While the speed of light is the measure of entropy as cause, the spin of all real and virtual particles is the movement of its effect. Since it is velocity of spin by which we measure the speed of light, spin can be classified in a higher dimension than the force of light, and which unifies the other four elemental forces. To say that spin measures a higher dimension, when in fact any good modern quantum physicist would be able to tell you that it only measures the three real and one additional potential dimensions of our universe, seems a little inverse. This is only due to the very ancient tradition of believing the mysteries of the universe are better off left alone as ineffable. Honestly, we are lucky to even know of depth, height, and length. In regular quantum physics, spin is measured in as many as 3 dimensions for real particles and as many as 2 dimensions for virtual particles. This is because a real or solid particle can be measured as a wavelength even while in motion, and its particle spin, or vector, and its polarity can also be measured by its being struck by another particle, while a virtual particle can only be measured as the wavelength frequencies of its orbital shell and either velocity or trajectory. In this way, we see that the way virtual particles spin is measured allows the introduction of the variable of duration, and this equates to the pulse duration as the length of the wavelength of a potential virtual particle or a moving real particle. And in this way, we know that virtual particles exist even when they are not being struck by a photon to be measured, similar to a zero acting as a placeholder. And it is by the length of wavelengths of the real particle photons that we measure time. Therefore, insofar as spin measures the 4 known dimensions, it is not so unreasonable to say that it may be utilized to measure a higher dimension as well. Since we have seen that tachyons are a particle of a dimension transcendent to time, it would seem only fair to say that their spin would represent an additional dimension to those 4 that are known. However, rather than this, what I would propose here is that the characteristic of spin itself is actually the substance of a dimension even transcendent to tachyons, since we have seen that tachyons' spin is involution. However, we have not assigned a complete set of characteristics to the behavior of spin itself. As I have said, vector is usually only used as a measure of particle spin, or the movement of a single point on the surface of a real particle. Since this movement is guided in 3 directions simultaneously, by orbital spin of polarity, trajectory spin of the whole particle's movement through space-time, and the spin caused by the inclination of the particle's polar axis, vector can refer to 3 different dimensions of particle spin. It can also be used as a name for the measure of duration, although this is not a common practice, since space-time itself is not yet commonly viewed by quantum physicists as a single, unified field upon which each particle itself is acting as a vector governed by the same laws relative to space-time as a fractal or a hologram. In this regard, a single vector can be multidimensional, and some quantum mathematicians have extrapolated different results as to the maximum quantity of dimensions a single vector can represent. Depending on the geometry of our universe, space-time may be curved in different ways, and thus affect particular different vectors on the local particles. There may be a finite number of ways in which this occurs, and if there are, it would seem to indicate that the relative geometry of curvilinear spacetime must be closed. However, there are other theoretical models that extrapolate base vector dimensionality to the nth exponent, representative of a sum that is greater than infinity and greater than the transfinite variables as well. It is because of the multidimensionality of the single vector that there is usually a prejudice against classifying vector as representative of spin as a dimension in and of itself. However, the same scientists would no doubt have to concede that a multidimensional universe, or a multiverse, would necessarily be of a higher dimensional order than the universe of minimal possible dimensions we know today. Therefore, the more dimensions a vector has, the more it is in an autonomous dimension, unique from the vectors of all the other particles. Therefore, think of a vector as similar to a person on the surface of the Earth. As the Earth rotates and the pole precesses, and as Earth orbits the Sun, so does the solar system orbit the center of our galaxy, and thus we are moving relative to billions and billions of other galaxies, each formed and guided by its own dimensional geometry. Not only this, but we have free will to move around on the surface of the planet wherever we wish, and moreover, we are perpetually regenerating our physical form, such that there is motion even within the point of the vector of a person on the planet itself, just as a tachyon involutes. If we subscribe to the closed geometry theory for the model of space-time of our universe, then we must accept that entropy reduces the number of possible dimensions to the minimum number it can. I have already shown you this is not necessarily true, but it is still the prevalent belief, and therefore the one I shall describe. In truth, we negentropic humans have created computing machines through which it is possible to enter into a virtual reality, in which the open geometry of nth exponential potential dimensions governs the laws of physics, and these are just as real in that they have been made and do exist, as is the universe outside of them in which our bodies of flesh exist. However much can be learned from this minimizing method, we see that it does indeed govern entropy, which is the greater factor in the universe than negentropic evolution. Even though this is the prevalent scientific practice, it remains elusive that the universe itself is, and always has been, nothing more than a first-dimensional singularity. Until recently, the singularity itself was nothing more than a theoretical concept, expressible utilizing the ideals of mathematics and geometry, however unknown in any natural forms beside the socially independent individual. According to Einstein's equations for special and general relativity, the space-time singularity was a statistical possibility, and it was not until the end of the last century that the black holes these were thought to cause were finally observed through a telescope, masked by the radiation that they were inside of consuming. Now it is known that there is at least one supermassive black hole at the center of every spiral galaxy, and that there may be countless other naked singularities, or black holes with no hair, electromagnetic field lines acting as attractive gravity, thought to be a particle unit of superstrings. The modern model of the black hole is based on a gravitational or rotating singularity that is emitting the attractive force of gravity and pulling the surrounding material of the continuum towards it. We know from tachyons that gravity is actually a repellent force that moves opposite entropy, and in this way acts attractively on the surrounding particles of the lesser dimensions it encounters. These surrounding particles are pulled towards the singularity and form a shell of radiation around it. It pulls matter apart further out, reducing it to light, and in the center, it is hypothesized, there is an area that even photic radiation cannot escape from, and this is called a black hole. It has also been hypothesized that the singularity in the center of every black hole is itself the medium of another, smaller continuum or baby universe. However, I have not yet specified sufficiently the difference between universes resulting from the temporal singularities, or faster-than-light wormholes between the black hole's event horizon and the spinning singularity, and universes resulting from the spinning gravitational singularity itself. The universes arising from the temporal black holes are illusory refractions of our own universe, parallel worlds. The universe in the central singularity is a mnemonic inverted reflection of the laws of physics of our own universe, as they are inverted beyond the speed of light, and then again when they enter the gravitational singularity. Here, in its raw form, is the microwave gravity of the universe itself. A temporal singularity is a tachyon. The wavelength of its projected trajectory is called a superstring, while we see that the tachyon itself is an involuting torus that propagates more of itself that are smaller and then grow. This classification of various different-sized faster-than-light microfrequencies by particle is in keeping with the standard pursuit of quantum mechanics to produce tables of quantum particles for the elemental forces, alike the tables of atomic particles for the same. The reason a tachyon is a temporal singularity is that it is moving both backwards and forwards in time at once. This is simply to say that its spin is moving simultaneously in opposite directions, and that, due to its surface area, a vector on one spot on its surface would not necessarily be moving in the same direction as another vector on a different spot on its surface. And, in fact, since its internal core is a phi over pi mnemonic spiral, it is actually bending the surface of space-time quite a bit. These exist on the very smallest level, and are so small that we cannot even prove them using modern machines. They are still only a theory, existing only in potential. Ironically, however, potential itself is the substance of the fourth dimension, for it is only through the study of statistical probabilities that we can predict the future. Therefore, to say that these particles exist in potential is tantamount to saying that they are only a matter of time, that is, a singular temporal possibility. It is this kind of singularity that occurs inside the neuron cellular pillars inside the brain, and why our mind is a singularity. They occur as well in the electrical fibrillation of the heart, and because they occur here as a pulse, configure geometric fourth-dimensional hypershaped meta-object thoughts perceived as emotions around us, forming our aura or electromagnetic soul, which communicates the continually changing contents of our minds as moods. Since wavelengths have been observed to propagate along relative planes, it is thought that the singular vector can also be extended onto a relatively flat surface. This theory, called M-theory, describes the surface of space-time as shaped by several different dimensional branes, each one warped in a different way, and this way describing the force that is warping them. All this means is that dimensionality itself is allowed to be thought of as planar, which is a hard conceptual leap to make, having just come from thinking of it exclusively as a point. However, let us examine the electron. When it is struck, it is a temporal singularity. The duration of its existence as a measurably real particle is called an event, and this is called 1 Planck time unit, used as the standard shortest measure for the progression of time. The electron, when it is struck, and has compressed itself into a singularity-sized point of electrical charge, can be measured by its orbital trajectory, which is planar, and its electrical charge, which is polar. We are not looking at 4 dimensions here. We are looking at 2 dimensions that are both potentially 2-dimensional. In other words, M theory is correct. Every single dimension can be expressed as alike a 2-dimensional plane with 2 opposite potential surfaces. In this way, not only does every vector express multiple dimensions, but even more so is every singular dimension an expression of multiple potential dimensions. This leads philosophers easily into the age-old debate of dimensional levels and the hierarchy of the heavens reflected in our consciousnesses. It would be easy these days for a child to reason that we are living in a multiverse of tunnel realities, and that the surface of space-time was little more than a graphic user interface system. Of course, for an adult to do the same would probably get them arrested. However, both these facts only serve to indicate that computer technology has, indeed, penetrated the collective unconsciousness with digital newspeak, and is leading the common consumer down multiple roads at once in the capitalist garden of forking paths. However, any ancient Kabbalist can also remind us that the first names for cognitively dissonant thoughts that occurred in the same mind were Satan and Moloch. Because it is an electrical charge, the electron always has polarity, and this means that the charge orbits around the poles from one to the other so fast that it occupies every location in the shell or cloud at once, and it is only by being struck by a photon that its position or velocity can be measured. When this happens, its orbital plane becomes clear and can be deduced mathematically. When this is done, it is classed as second-dimensional, following the first dimension of the singular charge itself, with the polarity of that charge. The standard, or Bohr model of the atom, is one of possibly multiple electrons sharing the same distance orbital shell from the nucleus, and this means that the multiple electrons must never collide, and that their orbital paths cannot all be the same at the same time. In other words, even though the different electrons can be the same distance from the nucleus, supported on a framework of gravity-like microwavelengths emanating from the nucleus, and even in this way share magnetic polarity as the definition of their orbital trajectory, they must either be moving at different speeds or be located in different places along the orbital track of the electron cloud. Of course, the only way to measure this is to strike them with a photon, and then we see that doing so only restructures the electrons in their orbital shells and absorbs or releases more or less energy, in other words, changing the very same environmental conditions for the electrons that we would be seeking to measure. Because of the reliance on the photon, or real particle radiation interference, to study the nature of virtual particles, not much more than this is known about the electron, and therefore more profound questions, such as is the rotational vector of the electron cloud differential, like that of a gaseous body in space, are left just out of the reach of the long arm of the law of physics. It seems odd that, living on a spherical, three-dimensional planet, in a fourth-dimensional space-time, that many of the larger arrangements of heavenly bodies, between the third and fourth dimensions in scale, occur as second-dimensional. The orbital planes of the planets around the Sun are flat ellipses, and the path the Sun takes around the center of our Milky Way galaxy is a more or less flat spiral on one of the galaxy's more or less flat spiral arms. Stars are usually found in nebulae, clusters, and galaxies, which can have many different shapes. The most common shape of galaxies is a flat, basically pi, spiral. When stars are first formed in the gaseous nebulae by random spontaneous combustion, that is, nuclear fusion triggered by a concentration in gravity, they immediately take on differential electromagnetic rotation. This winds their electromagnetic field lines up around their surface, creating shorter, faster rotation around the poles than around the equator. Thus, as they are gravitationally pulled toward one another and attract or create planetary debris, they orient themselves according to this planar polarity. At the center of a spiral galaxy is a black hole. All of these black holes were once stars, and they continue to electromagnetically rotate differentially. Thus, their accretion disks, which can comprise vast galaxies many light years across, orient themselves along the plane of the black hole's equator. Older black holes have another feature. They eject exactly straight electromagnetic field lines from their poles into space, and this radiation is the faster-than-light, gravitational, superstring microwavelength of a tachyon. Let me describe space-time in terms of sound. Don't think of sound waves as merely the disruption of the air particles, but as a layer in and of itself underlying them. Sound waves, like any other form of wavelength, generate resonant frequencies. Each one of these has its own geometry, and these are what we call the exponential dimensions. According to the laws of physics, in the universe governed by entropy, where dimensionality is compressed to the minimum possible number, we see that only 3 basic tonalities in a harmonic accord permeate the entire universe. Whether or not our universe is governed by the law of entropy is determined by whether or not there is restriction on the number of possible dimensions, that is, whether they are expressed as an open or closed set. Space is comprised of the 3 given dimensions. However, time, the 4th dimension, is separate from these and is in itself more complex, since it contains the 3 spatial dimensions within it. This is not a hard concept to grasp. Simply remember how cavemen counted with stones: 1 for 1, 2 for 2, 3 for 3, and 4 for 4, such that there would be 10 stones altogether. Having just described how the realms of space and time may be thought of as separate, it is important to remember that they are really one and the same. At the center of every intersection of the spatial and temporal dimensions is a fluctuation in potential towards probability, either a temporally singular virtual particle or a real particle that will ultimately end up as a gravitational singularity. Therefore, every one of these intersections is potentially two-dimensional, with space-time on one side and time-space on the other, containing space within them, with the fourth dimension of time outside. However, since each of these was a temporal or gravitational singularity, their ability to be expressed as upon a continuous surface also expands itself into what we know as height, depth, and width. Thus, that which is inside the surface of the intersection of the three spatial and fourth temporal dimensions is the history of singularities flowing backward on a gradient from the more ideal temporal end of the spectrum of entropy into material form, and then dwindling into nothingness and returning again to the ideal realm. When these gravitational singularities become black holes, they emit extremely straight electromagnetic field lines from their electromagnetic poles. This radiation travels faster than light and is made up of tachyons. Since tachyons are above the limit of the speed of light, they are even more sunk into the temporal dimension of pure potential than the potential energy of electrons. Therefore, it is easy enough to conceptualize of another wave of tachyons at an exact right angle to one occurring naturally in the gas jet of a black hole, and quite right to say that, in potential, it exists. Then it would be only natural to expand this to include as many more tangents at right angles as possible, and here we see that entropy has already limited us to only one, which gives us a total of 3. Tachyons may not be able to provide a constant velocity any more stable than that of photons, but they are nature's straight-edge rule. Because the tachyons themselves are so very small, their measure of dimensionality can be applied even on the scale of the smallest known quantum particles, and in this way, by being mapped onto the surface of a particle, be used to plot the vector of its spin in the space between quantum particles as well as its particle spin. One of the most common of these types of vectors is the phi spiral, where the very dimensions of a particle itself are drawn by microwave gravity toward those of another. There are 2 types of spin that a particle can have. Particle spin, or the intrinsic spin of a particle itself, can be measured in polar rotation, polar precession, and polar displacement. Each of these is assigned dimensionality for the measure of its contributing vector. However, their cumulative effect can be compressed down to a vector expressed in even only one of these dimensions. The other sort of spin is projected trajectory, and is measured as a wavelength only, a 2-dimensional history describing a trajectory in 3-dimensional space compressed into a single dimension. This is the only way available for the measurement of virtual particles in states such as the electron cloud, since it is only when it is struck by a photon that the otherwise unknown dimensions of its charge and its polarity can be observed. It is also the dimension given for real particles over time, and in this way shows the link between the potential energy of virtual particles and the temporal dimension. There are no such things as real particles. As real particles are defined, all existing matter in the universe was created from energy, and will return to energy again in the end. Random quantum fluctuations in potential allowed probability through from outside the universe, and filled up quantum units with the information of spin. These will carry on as long as their spin continues, and the lifeline of most real and virtual particles in our universe is destined to end in the gravitational singularity at the center of a black hole. Black holes will continue eating our universe until all that is left is the background tachyon field radiation. The evidence given us in our school textbooks also reinforces the truth of the fact that this has already begun to happen in the furthest reaches of our universe and is sweeping in a giant wave right toward us in all directions. In fact, most of what we can see of the visible universe is the information carried to our eyes by photons emitted from very distant stars that died out long ago, and therefore it is not even safe to believe our very own eyes, for photons themselves are lies and do not represent instantaneous information transport. The mask of photic light worn by the universe is an illusion, concealing the fact that most of the universe is already dead. Such is the ultimate gnosis, that nothing exists and that nothing is real. The most real thing that remains is mathematics, and it is therefore only because vector can be represented according to a mathematical model that modern scientists rely on its reality. The mathematical model of the vector is the matrix, a quantum mechanical or wave mathematical set theory. In this, the number of potential dimensions in space are given perpendicular to the number of potential dimensions in time, such that they form a cross-reference system or number lattice, similar to a magic number square. Vector itself is represented as the transformation of the spin statistics in a diagonal across these interfacing dimensions, usually expressed in either whole number or as fractions, while the other probabilities are expressed in reflexive binary on either side of the diagonal. Matrices can also be produced using fewer spatial or temporal dimensions than the other, such as in only one spatial or one temporal dimension being a singularity. To understand this concept, it might be easy to look at the machinations of popular culture fads and trends and slower social agendas through the mass media. Since the media is not only one person, but very many persons, and not one machine, but very many machines, it does not present a picture of a single individual, but of a unified mass working all together for a common, ever-changing goal. Imagine, therefore, all the components in the media as if they were like pixels on a screen, whose face seems to appear, whose should, what shapes seem to appear, what should. This is the history of the changing of the human mind. Although there are an infinite number of possible trajectories that can occur in the interatomic space, a few seem to occur more regularly than others. These are the microcosmic representations of entropy, since they also arrange themselves as fractal or infinitely self-terminating, and mnemonic or infinitely self-replicating geometric patterns. The fractal patterns occur at points of symmetry breaking, when the prior trajectory assumes a less ordered, more chaotic path. This occurs when energy is liberated. These patterns do not last long because the liberated energy and free particles tend to reaccumulate themselves towards one another due to microwave tachyon gravity. At these points of spontaneous symmetry formation, we see stable patterns propagating ordered change according to even cause and effect. Two such negentropic patterns are the phi and pi spirals. Phi spirals occur when symmetry is broken and immediately resets itself. This is pure dimensionality in the form of spin, acting on the principle of nature abhorring a vacuum, and immediately finding pattern as soon as a previous pattern has been lost. The phi spiral pattern is taken by electrons changing energy level shells, for example. Phi spirals extrapolate out from the diagonal of cube roots. Pi spirals are even more prevalent and abundant in the quantum world than phi spirals. Pi spirals comprise the orbital path of the electrical charge in the electron cloud, as well as the orbital vector of all polar real particles. Pi is also the pattern that governs the rotation of our planets around the Sun, and stars such as our Sun in spiral galaxies around black holes. Pi spirals obey the law of inverse squares. Before there were spherical, real particles of solid matter formed by raw probability, there were microwave fluctuations in the subspace continuum comprised of pure potential. These generated the spinning real particles by swirling in upon themselves in a vortex that inverts itself and is filled with dimensionality by the vector information units that are the aggregate sum over histories of tachyons. So, when any real particle finally disperses or is obliterated in the center of a black hole, it resorts itself into the ambient energy of these wavelengths. Almost all of the known universe is comprised of electromagnetic background radiation. This includes the real photons that we see, as well as the entire rest of the otherwise invisible to the naked eye spectrum of radiation, from infrared to ultraviolet, not to mention microwave tachyons. The study of wave mechanics in general is therefore a rigorously mathematical discipline, since mathematics express the equations and axioms that govern the variable world of quantum uncertainties, and can describe elegantly concepts which, if expressed using solid structure models, would only be needlessly cumbersome and bulky. However, in the same way that the sums, variables, and equations can express the quanta themselves, still geometric lattices may be employed representing such fourth-dimensional holomnemonic metaforms as the tesseract to express certain quantum relationships. It is speculated that, in the same way that we can perceive the formation of alpha wave forms inside the brain through the rapid eye movement of dreaming sleep, so too our entire universe itself might be fluctuating between the moments, being obliterated into nothingness and instantaneously reassembled perpetually. This is the premise of simultaneous expansion and contraction, upon which the tapestry of dimensions in the multiverse on the surface of space-time unfolds. The ancients perceived this measure of time as the continuum's inversion between existence and nothingness, or, at the very least, units of information and light. They identified the implosion of contraction with Draco, the constellation surrounding 11 of the 12 houses of the zodiac in the very northernmost of the celestial hemisphere, and containing a star that was once the pole star. This cycle was described by the Hindu as the snake of Manvantara that was turned by Vishnu, and it was commemorated in the architecture of Angkor Wat, the buildings of which are designed to align with the stars of the constellation Traco. It is also identified in Hebrew literature as Zimzum, and in Greek as the Ouroboros, or snake that eats its own tail. The inversion of this was associated with the Tao of the Kabbalah, and the lifting of the flaming sword from its setting in stone. As the electrical charge of an electron travels through subspace, it oscillates its course around a series of probability wells that it forms from the raw potential. Because it only illuminates one at any point along the time measured by the wavelength, the electron cloud itself is said to ride along on only one well. However, in reality, it is the weaving around first one side of one probability well, then around the opposite side of the next, that produces the familiar shape of the sinusoidal wave. The quantum tunneling of an electrical charge through subspace, or of tachyons through hyperspace, is very different from the emission and absorption that occurs between real particles and virtual particles. In fact, the tunneling propagation of tachyons is unique even from that of the relatively slow electron, which only follows one wavelength. The tachyon, being a particle of a higher dimension, follows 3 wavelengths at once. 2 opposite vectors trace around the outside of a probability well, doubling the effect of the electron. The other path, however, passes straight through the probability well of potential event, just as might an electrical charge from one well to another, if a series of electrons were aligned in a line along their poles. However, whereas the electron would still follow a path outside the wells along these poles, the tachyon goes through the poles, and it does this not just in a straight line. It disappears into one side of the probability and reappears out of the opposite side instantaneously. The additional velocity is conserved by the field lines that surround the well the tachyon is tunneling through. The longer these surrounding field lines, the straighter the internal trajectory of the tachyon as it tunnels. This is very different from the emission-absorption between real photons and virtual electrons. Photons emit tachyons, and electrons' energy-level orbital shells are sustained as hollow mnemonic resonances upon tachyons. Thus, there is a similarity with which photons and electrons can communicate their spin and energy to one another. The reason that the energy shell level of the electron expands when it absorbs a photon and contracts when one is emitted from it is that its quantity of tachyon potential has expanded on the opposite side of the surface of space-time from the energy of the electrical charge itself. It is for this reason that subspace matter traveling through hyperspace in a tachyon wormhole is said to cast a subspace shadow of indeterminate probability, just like the electrical charge on the other side of tachyon energy. Whenever there is any movement in the universe at all, its inversion is reflected in a higher dimension or dimensions. This is the principle of the conservation of counterspin, or reverse spin, in potential, or on multiple higher dimensional levels. In this way, the same mechanism of conservation that counterbalances entropy only serves to propagate it further in the hyperdimensional multiverse sum over histories of our universe. Therefore, the law of the conservation of counterspin may as well amount to the rule of universal irony. According to this law, We are moving forwards and backwards through time. As we move forward in time, we are also moving backwards in time through ourselves all the time. The mathematical study behind the concept of motion, supported by the naturally observed theorems, axioms, and formulae, is based on the study of three separate fields, each of which can itself be read as a dimension. First, there is the field of topology, which is based on the surface mapping of an object. The second is set theory, or the theory that all objects whose surfaces can be mapped can be graphed as a set of numbers. The third is matrix mathematics, the purely number field that theorizes the digital representation of the object's motions according to the set of numbers of its topological graph. Since manifolds exist in the fourth dimension, it would be fair to say that a manifold is even one more further step in this long sequence of events in transformation. It is the graphing of a matrix on a theoretical surface such that the effects to the number set may be predicted for any given vector. While it can be said of the human state of consciousness as it has passed through this many in a series of transformations, that it might be changed and wander, an objective measuring device, such as represented by the manifold, does not change between transformations of form and establishes a fixed pattern of spin symmetry from one mode to the next. To describe what function a manifold performs geometrically, it would be right to say that it measures. It measures as numbers that can be graphed, plotted, and coordinated, and it measures as a surface area which is comprised upon that number field. It does this in the ideal realm of mathematics, well enough to be able to make predictions for movement to one neighborhood set on its surface relative to another when the values of the sums are known that define, delimit, and determine its motion. What can be known of an idealized manifold in itself, therefore, is only that which may be perceived as upon the surface of the intervening field of math. Because math itself can be reduced in this way down to a flat dimensional brane separating the real and the ideal, it should be noted that the fourth dimensional manifold shows through by interpenetrating multiple fields of mathematics. For example, within the study of the mathematics of manifolds, the fields of set theory and topology are unified. Sets are something like number lines. The original concept of the number line was that at each equally marked unit, there would be the next in the sequence of units, where the center of 6 such number lines, the origin of a Cartesian graph such as used to measure three-dimensional space, was marked by 0. Imagine a three-dimensional graph that has a portion of it divided against another portion, say as in a hyperbola, such that what is on one side of it is measured as against what is on the other side of it. This is the basic theory of the set. What is in each half of the so divided graph is its own set, with its own definitions, diameters, and parameters, all of which add up to figures. Therefore, a set is usually thought of as a set of these such numbers, and therefore even the two number points of any single point within a second dimensional fixed coordinate system are considered a number set. The only difference between a set and a number line is that of depth of dimension. A number line is bound to expression in only two dimensions, establishing either up-down, right-left, or forward, backward, and a distance. A set, on the other hand, can be a quantity with mass, weight, substance, and volume. For example, the bagel I eat in the morning can be thought of as a separate set of matter molecules from the plate I eat it from, or the glass of water I drink with it. This seems about comparable to introducing what will be discussed in further detail later on, the shape of the torus as a four-dimensional manifold. The torus, just like the bagel, though an idealized form, is a self-enclosed set. Another name for this is self-embedding or self-referentiality. These are fourth spatial dimensional traits equivalent to third spatial, fourth temporal, self-enclosed sets. The torus, as we will see later, is an exemplary four-manifold, a certain kind of a set that possesses many numerically expressible traits. As I have already explained how number sets can be derived from topological graphs in order to introduce the theory of sets, perhaps it would be best to also come backward at the idea of topology and begin with the smallest number set, the single point of a coordinate pair. This is clearly a set of two numbers. Taking its absolute value, we see that it can only have referentiality to a greater, more inclusive set, such as a number line, plane, or some other graphical function, and has no meaning on its own. Imagine these numbers as being representative of dimensions. Thus, the coordinate pair is also the smallest form of a matrix. While the coordinate pair's numbers refer it to placement in a numerical graph of number lines in 2 or 3 dimensions, the smallest form of matrix is binary code numbers representing the presence or absence of spin along 3 separate vectors, each in its own dimension. So we see that the only difference is that one represents a stationary point in multidimensional space, and the other a moving spot in multidimensional space. To determine the difference between the two, we must introduce topology. Topology is simply the expansion, either arithmetically by coordinate pairs or exponentially by spin, of a number set to derive constituent shape. There are several methods of doing this. One such, for graphing singularities in 4 dimensions, is the blow-up method of manifolds. This consists in adding extra dimensions until the surface is hyperbolically or asymptotically curved enough to yield a measurable manifold neighborhood or numbered subset around a centralized singularity. A more common method is to simply further extrapolate the formulae through which the original coordinate pair or number matrix derived. It is usually the behavior of the other variables than the numbered pairs or matrices in formulaic equations that governs the full shape and motion of the object being observed. However, it is possible to expand upon just the numbers alone. The coordinate pairs can be expressed as angles in degrees or pi radians, imaginary numbers or fractions, and the matrices can be of multiple vectors in multiple dimensions, possess more or less symmetry, be more or less in binary, and also can use fractions. The set of all sets that possess topological characteristics is called the set of all manifolds. A manifold is acting as both a number set and a topology simultaneously. While the example of the blown-up singularity pertains here, There are an infinite variety of manifold types and forms. As I said earlier, also, the bagel is like a manifold. The difference between the bagel manifold and the blown-up singularity manifold is that the bagel is real, while the singularity is ideal. This is not to say that the bagel manifold is real in the same way as the set of all real numbers manifold is real, or that the set of all real numbers manifold is in any way less ideal, or even less than identical, to the graph of a singularity itself. In fact, the graph in 3 dimensions of all real numbers would have to curl over and under to connect to itself, as would the physical dimensions if they were compressed around an actual singularity, whether that of the charged electron, the temporal torus, or the gravitational singularity. This shape is also a well-known manifold, and it is called the trefoil, or triple bound knot. A trefoil, in one fewer dimension, is a torus. A torus is a hypersphere at antipode. There are manifolds for all the regular solid polyhedrous metaforms that exist in the ideal realm of potential as well. A set, in itself, such as a matrix or coordinate pair, cannot possess spin, only describe it. A topology can spin, but without measuring out vectors on it and plotting them numerically into a system such as coordinate pairs or a matrix, the exact nature of this spin cannot be deduced. A manifold is there to bridge this gap. A manifold can spin, and by careful deduction of the formulae governing its behavior according to the laws of classical physics, the measurements of such spin can be entered in as vectors into matrices. Therefore, while it is comprised of sets and topology, it is not bounded by either one of them. Unlike them, a manifold can have measurable spin. One of the main ways to know that spin is measurable on a manifold is to establish a matrix for a set within the manifold. This process involves first the establishment of a given manifold, and then the establishment of a neighborhood on the manifold. The number set for a given manifold is expressed as a sheet, which is defined graphically as a field and as a function in a physical formulae. Once a sheet has been constructed, a matrix can be formed for it based on the Fourier transform of the sheet, an equation the processing of which factors in spin or motion of the sheet relative to the remainder of the manifold. Doing so produces a vector matrix for the sheet, which digitally represents its spin, and therefore the spin of the manifold as well. Sheets are usually given only second-dimensional depth, or assigned variable coordinate pairs. This expression of them, therefore, renders them flat planes on the manifold neighborhood, and their relative number sets bound to binary. This means that their spin must be expressed as a fraction between the binary numbers 1 and 0, and the graph of their matrix plotted accordingly. This makes them equivalent to the electron's orbital plane between the binary dimension of its poles, or like the flat accretion disk of the standard spiral galaxy orbiting around a central black hole. This does not necessarily mean that the shape of the manifold to which the set is bound automatically complies to the torus shape of these two types of physical occurrences. While it can easily be seen to comply thus, the actual manifold shape can be in any form, because it is essentially describing a plastic, malleable consistency. The second-dimensional sheet is only used as a matter of convenience for certain types of mathematical procedure, such as transformations that we will get into more deeply later, and is by no means an axiom in and of itself. Just as the dimensionality of a matrix, a number line, a function, etc., can all be expanded and contracted to fit the requirements of convenience and elegance, so too can the dimensionality of the sheet and that of the manifold. The other common kind of sheet is the vector set, where the only information comprising the sheet is made up of a Fourier transform's formulaic equation, or a matrix. For such a sheet as this, there is a little additional information governing its composure or construction than what is being measured of the set in terms of its motion. It may be that the given matrix occurs within a larger equation for the determinant of the neighborhood set, or including the variable of the manifold itself. Usually the operative components in such a larger equation that are determinant of the spin of the manifold are given. In such occasions we see the relationships arise between the different sets as one of them can be derived from another through spin. When a manifold is mapped as the topology of a number set, such as the set of all real numbers, and the element of spin is introduced, certain other number sets can be produced, such as the set of all real quaternions, etc. Just as with the second-dimensional sheet set, it is easy to determine spin, so with a vector set, or matrix, is it easy to determine the effects of spin. While a Fourier transform can render a vector, or wave function, for any given particle or manifold, a Lorentz transformation generalizes this onto the rest of the surface of the particle, or the topology set of the manifold. A Lorentz transform is not harder to calculate than a Fourier transform, but the two are very different from one another. A Fourier transform creates a wave matrix for any given vector, representing this numerically as being relative to binary symmetry. A Lorentz transformation is more like a linear equation through which an extrapolation can be factored. One type of Lorentz transformation produces the set of all real numbers. In this transform, a torus shape is usually used, although a trefoil could work just as well. The idea is that the ends of the number lines arc around parabolically until they all connect with one another. Doing thus is called in topology attaching a handle to a handle, and it forms a torus shape. When this is done with 3 handles, it is a trefoil. Another name for such a kind of torus is a Mobius band or Mobius strip. The Dutch artist M.C. Escher, who is famous for his depictions of optical illusions, was proficient in the use of such a Mobius band, which he frequently portrayed with a half-twist in the common symbolic description of infinity. A trefoil is a Mobius strip with 3 full twists. There are many such depictions for the sets whose dimensionality expresses self-referentiality, and these are classed under the heading of knots. When speaking of topological knots, we must begin with the set of quaternions. The plot of this graph has little, if any, definite form to begin with, and yet has strong aspects of spin. Thus it is better known what the Lorentz transformation of the set is than the topology of the original manifold itself. I have described quaternions elsewhere in this exposition, however it would do well to go into them here again in brief. They can be extracted from the dark spaces of fractals when those fractals are given spin, and their appearance thus is only weakly symmetric, and usually is like a cloud of spun sugar that has been set in rotation. Thus, the plot of the Lorentz transformation for a quaternion would only produce a globulous cloud cluster rotating around itself. However, due to the integrity of its internal composition, it would be just as appropriate to refer to the manifold of its matrix as a knot or knotted. The number of manifold topologies that can have symmetrical number sets as matrices is not limited to the study of handles, toroids, trefoils, or even twists in knots in general. There are many different geometrical shapes that possess an axis of symmetry around which they can be rotated with the bulk of their weight evenly distributed, and many of these with multiple such axes of symmetry. For example, the zonahedron of a cube is one such geometrical shape, and so is the tetrahedron, as is the isosatetrahedron in higher dimension. There is no limit to the number of sets with symmetry that can be expressed as manifolds possessing spin. They are truly infinite. One of the most useful of modern-day manifolds is perhaps the four-manifold. This has been written about extensively in the last recent half-century, and will undoubtedly only become more useful. The most basic types of four manifolds are the basic polyhedral metaforms. These include the hypersphere or torus, hypercube or tesseract, two hypertetrahedra or simplexes, the 5-cell and 16-cell, the hyperoctahedron or 24-cell, the hyperisosahedron or 600-cell, and the hyperdodecahedron or 120-cell. Four manifolds also include, however, all of the other metaform polyhedra that might exist in 4 dimensions, as well as all the other rotational axes that each may also possess that would create alternative 3-dimensional lattice metaforms as 3-dimensional shadows of their shapes. These are only the rudimentary 4 manifolds, of which class there are an exponential amount from those which exist in less dimensions. These sort of shapes have proved useful in many different fields. They have been used as lattices in the sciences for constructing flowcharts of relationships between variables, and they are also similar to the form and nature of buckyballs, extremely large macromolecules of carbon that are contained everywhere in nature, serving various different kinds of functions, including smaller molecule carbon transport in the blood. Considering that life as we know it is carbon-based, these macromolecules perform a very important function. Beyond this, there are even more unknown 4 manifolds. There are as many different kinds of manifolds in 4-dimensional space as there are shapes and objects in 3-dimensional space over time. All of the natural patterns we perceive in all everyday objects are only shadows of these forms which occur in higher dimensions. Most of the examples I have used for descriptive purposes in this book have been 4 manifolds. Primary among these is the torus. The torus is derived from the hypersphere in antipode position, from where we can see that the hypersphere appears to be a tube wrapped around in a circle and connected to itself. From apogee, it appears to be a single circle, and from perigee, it appears to be a sphere nested within a sphere. All of these positions describe the same shape, however. Each one is uniquely different as a shadow in 3 dimensions. The shape they are describing is a 4 manifold. It can be depicted 2-dimensionally as a diagram in which 2 chords wrap around each other in knots to form the outline of the shape, or in which it can be thought that 2 two-turn cylinder sets, handles, have been attached to each other by the intertwining and knotting of their topologies. Phi over pi is a very important concept in measuring the torus shape, because it is the description of a vector on its topology. As a point on the torus shape's surface would follow a phi spiral path as it wound down into the interior of the torus, so too would it follow a pi spiral path around in a circle out again, as well as perpendicular to this as it spirals around the rotating circumference of the torus. Just as the torus had different appearances at antipode, apogee, and perigee, so too does the hypercube. At apogee, it appears as a regular cube. At perigee, it appears as a cube nested within another cube. At antipode, it appears as a tesseract, or two cubes of the same size joined to one another at every corner by 45-degree angles. While the torus shape is prevalent in nature as a recursive harmonic resonance, the hypercube is expressed repeatedly in the square and cube exponent functions of physics. Prime among these is E equals mc squared. Just as with the torus, phi over pi is the measurement of a tesseract. It is the measure of the difference between the internal and the outer cube over the measure of the internal cube in the nested perigee form, and it is the measure of the cube over itself for the singular apogee form. This relativism between the sphere and the cube in higher dimensions is important because it implies that, perhaps, in an even higher dimension, the two shapes are entirely unified. Lattices exist, as I have said, to depict the other fourth-dimensional metaforms. These include the hypertetrahedron, hyperisosahedron, hyperoctahedron, and hyperdodecahedron. Each of these would have at least one figure to represent them each at apogee, perigee, and antipode. For example, the hyperoctahedron at antipode, or the three-dimensional shadow as seen from above one fourth-dimensional corner, has a cuboctahedral envelope in orthographic projection. The Kabbalah can be expressed as a manifold. Doing so means that it functions at multiple levels and in multiple dimensions. This means that it passes through different phases and different forms as the different parts of it pass through the portions in space that are governed by the different dimensional geometries. Insofar as it underlies and interpenetrates reality, the manifold of Kabbalah is equivalent to the will of God. There are many forms that such a complex idea can take, and they have usually been studied piecemeal by academics and mystery scholars in disparate parts of the world. As four manifolds are becoming more popular among mathematicians of today in expressing topologically complex histories, such as quaternions, so too can they be incorporated to the historical flow of ideas associated with Kabbalah. Kabbalah, in and of itself, is not quite rightly confined alone to the expression of topologically complex histories. However, it is expressed in the realm of ideal, that is, the one as ideation and the other as mathematics, such that we can see how, topologically, the two can be intertwined in a knot. The scrying of John Dee and Edward Kelly on the tiling boards of the great watchtowers of the four cardinal directions that has come down to us of this day in document form somewhat resembles the plot of spin in a number matrix. In a number matrix for multiple vectors in multiple dimensions, this is usually represented as a diagonal across from corner to corner of numbers around either side of which there is binary spin symmetry. While we cannot directly deduce spin from the gematria of letter-number equivalencies in the tiling boards, we can only conclude that the scrying of the angel names by the connection of the letters resembles vectors on a Cartesian coordinate system. For a long time, magic number squares have been associated with the planets and with some of the stars and constellations. Some of the earliest calendrical astronomical observations were made by the patriarch Enoch, and these were handed down through the centuries to John Dee and Edward Kelly, who further classified the sets and theories by graphing them on a letter tiling board, which is itself much like a magic number square. Sometime in between the observations of Enoch and the scrying of Dee and Kelly fell the Abramelin squares, which are now largely incomplete. These gave letters, supposedly whose number equivalencies formed some sort of magic correspondence. Elsewhere, I have demonstrated that the 231 gates of the Sefer Yetzirah, as given by Alexander Rokich of Worms, can also be looked at as a set of magic number squares that together form the vector matrix of a larger manifold shape. It is probable that the King-Wen sequence of 64 hexagrams is meant to represent pairing in chromosomes during mitosis. There are 64 codons in each unit strand of DNA when it is wrapped around nucleosome cores to form the chromatid fibers that duplicate and split during mitosis and meiosis. The 64 hexagrams are numerically commutative with the 22 letters of the Hebrew alphabet, or 22 visible faces of a tetrahedral band of DNA. They are also commutative with the 72-letter name of God, the Shemham Farash, by the addition of the 8 double hexagrams formed from the 8 trigrams. The 8 trigrams form the basic oscillation of a fluctuating resonance field expressed as the 64 hexagrams. As such, they can be likened to a symmetrical matrix sheet for the manifold of the 64 hexagrams.